Hello everyone, welcome to our channel. Today we'll be discussing the second problem of mixed design. So let's get started. So this is the second problem of mixed design. So firstly, these are the steps to solve a mixed design problem which have already been discussed in the previous video. So let us directly come to the problem. This is the problem that we are going to solve today. Determine the proportion of the ingredients of concrete using IS code method from the following data. So this is almost similar to the previous question, just yet a extra diya ase that also find the actual quantity required for 1 bag of cement for the surface water and water absorption condition of aggregates. So our question to okol ami ratio to uliaisilu of cement is to fine aggregate is to coarse aggregate, but in this question we also have to find out the actual quantity of all the materials for 1 bag of cement. And for the condition surface water and absorption condition, jiduta amak question of extra data hisabe diya ase. We can see in point number 8 and point number 9 that we have the water absorption and the free surface water content for the fine aggregates and the coarse aggregate. This part is the additional part which is different from the previous question, and also our question to amar kuno dhoroner admixture use kora nasile, but in this question we have it is given in point number 6 that a chemical admixture is used, that is superplasticizer. So let us see how to solve the problem. The first step is the target strength for mixed proportioning, so which we get from clause 3.2 of IS 10262/2009. Yet a formula to diya ase FCK dash is equal to FCK plus 1.65S. This has already been explained in the previous video. So these are the from these tables we get the value of S, that is the standard deviation, from table 1 of IS 10262/2009 or table 8 of IS 456/2000. Yet corresponding to the grade of concrete we get the value of the standard deviation, that is the S in this formula. So let us solve step 1. From clause 3.2 of IS 10262/2009, we have FCK dash is equal to FCK plus 1.65S. Now what is FCK? FCK is given in the question as the characteristic compressive strength required in the field at 28 days, that is 30 Newton per mm square. Our S2 ki hoy? S2 has standard deviation that we will get from these tables. Amak grade of concrete ki hoy amar M30, karon characteristic compressive strength at 28 days is 30 Newton per mm square. So corresponding to M30 we have the value of S as 5. Similarly from this table we get the value of S to be 5. So here we can write down from table 1 of IS 10262/2009 or from table 8 of IS 456/2000 for M30 we have S is equal to 5. Therefore FCK dash is equal to FCK amar kiman asile 30 plus 1.65S, so 1.65 into S is 5, which is equal to 38.25 Newton per mm square. So this is the target strength. Now let us come to step 2. Step 2 is the selection of water cement ratio. Now selection of water cement ratio ami kor pora pam? From table 5 of IS 456/2000. Yate ama corresponding to different exposure conditions and also for different grades of concrete, both for plain concrete and reinforced concrete, amak maximum free water cement ratio or minimum cement content দিয়া আছে so ইয়াতে আমাক questionত একো mention কৰা নাই so we will consider it to be reinforced concrete আৰু questioner মতে আমাক exposure condition দিয়া আছে severe and আমাৰ grade of concrete হৈছে M30 so আমি maximum water cement ratio কিমান পাম 0.45 আৰু minimum cement content আমি পাম 320 kg per meter cube but this 320 kg per meter cube যেটো minimum cement content হয় this is only applicable for aggregate size 20 mm যদি আমাৰ 20 mm তকে বেলেগ হয় then we have to make certain adjustments and these adjustments are according to this table 6 of IS 456 2000 ইয়াতে আমাক বেলেগ aggregate size ৰ কাৰণে বেলেগ adjustments দিয়া আছে so now let us come to the solution of step 2 that is the selection of water cement ratio so we can write down from table 5 of IS 456 2000 for M30 grade of concrete and for severe exposure condition maximum water cement ratio amar kiman asile from the table we get maximum water cement ratio as 0.45 aru minimum cement content as 320 kg per meter cube so let us write that down maximum water cement ratio is equal to 0.45 আমি maximum to কেতিয়াও নলো আমি usually অকমান lesser value law so we can adopt the water cement ratio as 0.40 আৰু minimum cement content কিমান আছিল আমাৰ minimum cement content is equal to 320 kg per meter cube but this is for aggregate size 20 mm but our question of aggregate size kiman dia ase 40 mm so we have to make the adjustment and adjustment is from table 6 of IS 456 2000 yate amar aggregate size or respect of amak adjustment to dia ase amar question of aggregate size kiman 40 mm so aggregate size is 40 mm so corresponding to that our adjustment kiman hoy to minimum cement content it is minus 30 so we have to deduct 30 from 320 kg per meter cube so we can write down from table 6 of IS 456 2000 for 40 mm aggregate reduce 30 kg from minimum cement content so minimum cement content after adjustment is equal to 320 minus 30 is equal to 290 kg per meter cube. So this is the completion of step 2. Next we come to step 3, that is the selection of water content. So etu ami pam from table 2 of IS 10262-2009. Yate amak for different sizes of aggregate amak maximum water content to diya ase. But to this table, the values that we get from this table, we have to make certain adjustments. And adjustments bilak ami pam from clause 4.2 of IS 10262-2009. Yate amak tinta type of adjustment ase. First two is for the shape of the aggregate, second is for the slump, and third is for the type of admixture used. Etu amar previous video to already discuss kora goise. If you haven't watched the previous video, I have linked it above. Do check it out. So yate amar ki diya ase, yate amar shape of aggregate diya ase subangular, jitur karone ami adjustment koribo lagibo. Slump is 50 mm, so we do not require any adjustment for that. And amak admixture diya ase super plasticizer, so hetu karone ami adjustment koribo lagibo. So we need two adjustments. So first let us see what we will get the water content. Amar ki diya ase, amar size of aggregate diya ase amar 40 mm. So for 40 mm size aggregate, our maximum water content is 165 kg. So let us write that down. For step 3, from table 2 of IS 10262-2009, maximum water content for 40 mm size aggregate is equal to 165 kg. Now what is the type of aggregate that we have, or the shape of aggregate? Type of aggregate is equal to subangular, which is given in the question. So subangular karone ami ki adjustment koribo lage, it is given here 10 kg reduction for subangular aggregates. So we can write down from clause 4.2 of IS 10262-2009, adjustment for subangular aggregates is equal to 165 minus 10, which is equal to 155 kg. Now next is the slump. Slump ama question at kiman diya ase. Slump is equal to 50 mm. Now from clause 4.2 we have, jodi amar slump for range 25 to 50 mm thake, we do not need to make any adjustment. So slump for karone yate kono dhoroner adjustment nalage. Hence, no adjustment for slump is required. Last amar ki ase, last adjustment is for the admixture used. Aru yate amar question at ki diya ase, admixture is super plasticizer. So as super plasticizer is used the water content can be reduced. Kimankhini reduce korim ami? For super plasticizers, we have to reduce it by 20%. So it can be reduced up to 20%. Therefore, gotekhini adjustment korar pisot final water content ami kiman pam? Water content is equal to 155 minus 20% mane 20 by 100 into 155, which is equal to 124 kg. Next we come to step 4, that is the calculation of cement content. So ami water cement ratio kiman adopt korsu, maximum asile 0.4. So we are adopting, let us try water cement ratio 0.40. The cement content kiman hoy? Cement content is equal to water content by water cement ratio. So water content ami kiman paisilo agor step 2 124, water cement ratio is 0.40. So this is equal to 310 kg per meter cube. Eta etu step duta check asile. First check is that it should be less than the maximum cement content, which is given in clause 8.2.4.2 of IS 456-2000. Sorry, in the previous video by mistake I had written it to be IS 10262, but it is IS 456. So the maximum cement content is 450 kg per meter cube. So yatke exceed koribo nalage. And the second check is that it should be more than the minimum cement content. So first to hoise amar it should be less than the maximum cement content, that is 450 kg per meter cube. That is maximum cement content as per clause 8.2.4.2 of IS 456-2000. Also, it should be less than the minimum cement content. Our minimum cement content to already ami calculate kore 290 kg per meter cube paisu. So this is greater than 290 per meter cube. 290 kg per meter cube. So we can write down also required cement content, that is 310 kg per meter cube, is greater than the minimum cement content. Minimum cement content ami kiman paisilu? Minimum cement content ami paisilu 290 kg per meter cube. So both these conditions are satisfied, that is it should be less than the maximum cement content and it should be greater than the minimum cement content. So both these conditions are satisfied, hence okay. So the next step is the proportion of trial mixes, jitu ami pam from table 3 of IS 10262-2009. Yate amak corresponding to the size of the aggregate, amak volume of coarse aggregate per unit volume of total aggregate dia ase for each zone of sand. So yate amak questionot ki dia ase, size of aggregate is given as 40 mm and amar sander zone hoise zone 3. So corresponding to these two values or these two data, our volume of coarse aggregate per unit volume of total aggregate kiman, it is 0.73. A2 amar valid hoy when water cement ratio is 0.5, which is given in clause 4.4 of IS 10262-2009. But amar jodi water cement ratio 0.5 otke beleg hoy, then we have to make the adjustment, jitu ami bujaisu already in the previous video. So let us write down From Table 3 of IS 10262 2009, volume of course aggregate per unit volume of total aggregate for the fine aggregate of Zone 3 and nominal maximum size of 40 mm aggregate. Kiman paisu ami from the table? Ami paisu it is 0.73. Now what is the adjustment that we need to make? The adjustment is required at the rate of -/+0.01 for every +/-0.05 change in water cement ratio. So this adjustment has already been explained in the first video. If you have any doubt, you can go to the first video and check it out. So yate amar water cement ratio is 0.4, so amar change hoise 0.1, change kiman hoise -0.1 change hoise, so ami adjustment korim +0.02. So therefore adjusted volume of course aggregate per unit volume of total aggregate is equal to, originally asile 0.73, ami plus korim 0.02 and we get 0.75. So if we have the volume of coarse aggregate per unit volume of total aggregate, we can find out the volume of fine aggregate per unit volume of total aggregate. How? By subtracting the volume of coarse aggregate from the total volume. So therefore volume of fine aggregate per unit volume of total aggregate is equal to 1 minus 0.75. 1 is the volume of total aggregate because I am per unit volume of total aggregate and 0.75 is the volume of coarse aggregate per unit volume of total aggregate. So etu ami pam 0.25. So here we can write down water content. Kiman paisu ami 124 kg or liters. Cement content 310 kg per meter cube. Volume of coarse aggregate per unit volume of total aggregate 0.75 aru volume of fine aggregate per unit volume of total aggregate is equal to 0.25. So this is the completion of step 5. Next we come to step 6, that is the mixed calculations. So in mixed calculations, firstly we consider the volume of concrete to be 1 meter cube. Next, we have the volume of cement, which is given by mass of cement by specific gravity of cement into 1 by 1000. Mass of cement ami paisu 310. Specific gravity of cement is given in the question 3.16 into 1 by 1000, which is equal to 0.098 meter cube. Next, we have the volume of water, which is also given by mass of water by specific gravity of water into 1 by 1000. Mass of water ami paisu 124. Specific gravity of water is 1 into 1 by 1000, which is equal to 0.124 meter cube. Now, in this question, in addition to the cement and the water, we also have the admixture. So, ami volume of admixture uliyabo laibo, which is given by the similar formula, that is mass of admixture by specific gravity of admixture into 1 by 1000. Aru mass of admixture to hoise amar 2% of cementitious material. Mane cement or mass ami jiman paisu, tare 2% hobo amar admixture or mass. So 2% hole hobo amar 2 by 100 into cement or mass asile amar 310 by specific gravity of admixture amar question or dia ase 1.144 into 1 by 1000, which is equal to 0.005 meter cube. Next, we have the volume of all in aggregate. So, volume of all in aggregate to ami keneke uliam? A minus B plus C. Agor question to ami okol A minus B plus C korisilo, but yate we have to do A minus B plus C plus D. Ami D2 jitu volume of admixture hoy hetu ami subtract koribo lagibo. So ami pam 1 minus 0.098 plus 0.124 plus 0.005, which is equal to 0.773 meter cube. Next, we have mass of coarse aggregate. Hetu ami pam E into volume of coarse aggregate per unit volume of total aggregate into specific gravity of coarse aggregate into 1000. E2 hoise amar volume of all in aggregate, jitu ami paisu 0.773. Volume of coarse aggregate per unit volume of total aggregate, ami already paisu 0.75. Specific gravity of coarse aggregate amar question or dia ase 2.64 into 1000, which is equal to 1531 kg. Next, we have the mass of fine aggregates with using the similar formula. So, E hoise amar 0.773. Volume of fine aggregate per unit volume of total aggregate ami paisu 0.25. Specific gravity of fine aggregate ami paisu 2.62 into 1000, and we get this as 506 kg. So next we have step 7, that is the mixed proportions. So yate ami eneke table khon banai lom, and water cement ratio amar kiman hoy 0.40. Materials ki ki ase? Cement, water, coarse aggregate and fine aggregate. Now our question to ami okol ratio of material ulaisilu, but in this question we also have to find out the material per bag of cement. Now quantity of material amar kiman? Cement ami paisu 310, water 124, coarse aggregate 1531, fine aggregate 506. Ratio of material ami keneke uliam? Gote gita ami divide korim by mass of cement, because ami ratio to hodai cement to ami law 1 hisabe. So etu ami pam 1. Coarse aggregate ami pam 4.94. Keneke pam 1531 divided by 310. Fine aggregate ami korim 506 divided by 310, ami pam 1.63. So amar ratio to ki hobo? Ratio is cement is to fine aggregate is to coarse aggregate. So amar hobo 1 is to 1.63 is to 4.94. Eta ami material per bag of cement keneke uliam? 1 bag cement ot amar cement kiman thake? We know it is 50 kg. So yate ami 1 to 50 de multiply kore 50 paisu. So coarse aggregate amar kiman lagibo for 1 bag of cement, and fine aggregate amar kiman lagibo for 1 bag of cement, hetu ami multiply korim by 50. So 4.94 into 50 আমি পাম 247 আৰু fine aggregate to 1.63 into 50 কৰিলে পাম আমি 82 also আমি water to কেনেকে পাম for one bag of cement আমাৰ water cement ratio দিয়া আছে 0.4 so water cement ratio দি যদি আমি multiply কৰো 50 আমি পাম the quantity of water that is required for one bag of cement which is equal to 20. The ratio of mixed proportions hoise amar cement is to fine aggregate is to coarse aggregate. So we'll get this as 1 is to 1.63 is to 4.94. So this is the ratio of mixed proportions. So question of jodi kono dhoroner adjustment dia na thake will complete the problem here but ama question of adjustment dia ase that is for water absorption and for the free surface water content of coarse aggregate and fine aggregate. So we have to continue to step 8 that is the adjustments. Now adjustments at ama ki dia ase water absorption kiman dia ase water absorption for coarse aggregate amak dia ase 0.25%. Water absorption for fine aggregates amak dia ase 0.1%. Now water absorption mane hoise aggregates khini jikhini water absorb kori loy jikhini ami add koru tar pa jikhini absorb kori loy that is known as the water absorption. So since ekhini pani absorb kori loise we have to add more water. So kunkhini pani ami extra add koribo lagibo coarse aggregator karone ami 0.25% extra add koribo lagibo aru fine aggregator karone ami 0.1% extra add koribo lagibo. So extra quantity of water to be added to coarse aggregate kiman 0.25%. So 0.25 by 100 into coarse aggregate kiman asile 247. So you get this as 0.62. Our fine aggregator karone kiman add koriba 0.1% that is 0.1 by 100 into 82. You get this as 0.08. Next we come to the free surface water content. Free surface water content mane jikhini pani agor pra surface ot ase aggregates or so hekhini ase karone ami ki koribo lagibo adjustment ot ekhini pani ami deduct koribo lagibo from the total quantity of water. So we write down free surface water content for coarse aggregate is equal to 0.40%. Free surface water content for fine aggregate is equal to 0.05%. So quantity of water to be subtracted from coarse aggregate is equal to 0.4% minus 0.4 by 100 into 247 which is equal to 0.99. Our fine aggregate 0.05 by 100 into 82 is equal to 0.04. So finally we come to the adjustments. Water karone kiman adjust korim ami originally amar asile 20 tate ami add korim water absorption karone jikhini absorb hoise ekhini ami extra ke add koribo lagibo. So coarse aggregator karone 0.62 fine aggregator karone 0.08 আৰু free surface water content ৰ কাৰণে যেটো আমি adjustment পাইছিলো এটা আমি subtract কৰিম so coarse aggregate ৰ কাৰণে 0.99 আৰু fine aggregate ৰ কাৰণে 0.04 so finally we get 19.67 kg the coarse aggregate ৰ quantity আমি কি adjust কৰিম originally আমাৰ আছিল 247 এটা water absorption ৰ কাৰণে যেটো আমাৰ water absorption to plus হয় aggregates ত আমাৰ minus হ'ব আৰু water ৰ কাৰণে যেটো free surface water content to minus হয় aggregates ৰ কাৰণে plus হ'ব so ইয়াতে 247 আছে water absorption কিমান আছিল for coarse aggregate 0.62 ইয়াতে plus হৈছিল ইয়াতে minus হ'ব 0.62 আৰু free surface water content আছিল 0.99 ইয়াতে minus আছিল so ইয়াতে plus হ'ব 0.99 so we get 247.37 kg similarly in case of fine aggregates amar originally asile 82 water absorption asile amar 0.08 jitu amar yate water karone plus hoise so yate minus hobo 0.08 aru free surface water content 0.04 yate minus hoise so yate plus hobo 0.04 is equal to 81.96 kg so this is how you make the adjustments for water the water absorption and free surface water content water absorption to plus koribo lage aru free surface water content to minus koribo lage and for the aggregates both for the coarse aggregate and for the fine aggregate water absorption to minus koribo lage and free surface water content to plus koribo lage so therefore actual quantity for one bag of cement we have one bag cement ot amar actual quantity kiman thakibo cement will be 50 kg because tate ami kono dhonor adjustment nokoru sand or fine aggregates ami kiman palu 81.96 kg coarse aggregate ami palu 247.37 kg aru water ami palu 19.67 kg or liters so this is how we solve this entire problem. Thanks for watching. Do check out our other videos on the channel. If you have any query, you can write to us at the email address given in the description box. Do follow us on our Facebook page. Do not forget to hit the like, share, and subscribe buttons. Also click on the bell icon to never miss an update from our channel.